the key is to understand that we are intelligent, and that's evolved itself. That didn't just happen. Planets don't come preformed with little green men. And the interesting thing about when Fermi introduced or had that offhanded statement, "Where is everybody?" 70 years ago, we didn't know nearly as much about our universe, our own solar system, our galaxy 70 years ago than we did today.
Welcome back to the Eye of Jupiter podcast. I'm your host, Tom Franklin, and today we have on Mr. Terry Adair. He has some books. He's an author. We're going to get into some things about the Fermi Paradox and many other things. I am looking forward to this. If you are looking forward to this, or if this is your first time here, please do me a favor, consider liking and subscribing. Hopefully I earned that subscription today. And if you'd like to, you can also become a member, get some episodes early, and anything over an hour that will be put into that's also in a separate section called Behind the Eye. That's what it's called. It's new. I still got to remember the name. All links in the description for my guests as well as myself. If you want to reach out to me, you have something you want to talk to me about, please do me a favor, just like my guest did today, Terry, at the Eye of Jupiter podcast at gmail.com. One more time, the Eye of Jupiter podcast at gmail.com. So with all that out of the way, let's welcome to the Eye, Mr. Terry Adair.
Thanks, Tom. Appreciate it. And thanks for the opportunity of sharing my book with you, Where Are the Little Green Men? And Where Are the Little Green Men?
My pleasure, man. My pleasure.
Oh,
I'm glad you're here, man. You reached out to me, dude, and I was like, I got a booking agent, and I was like, "Oh my God, I hope I'm professional enough to do this." Because it's all new for me, I'm like, okay, I appreciate that. Kind of working, and
yeah. It's a little new for me as well.
Where you? Yeah. Okay.
I'm in Lake Tahoe.
We'll get our timing down in a second. You're in Lake Tahoe. Lake Tahoe. I'm definitely in Mexico. Lake Tahoe, that is in the California-Nevada border, correct?
Exactly. If you look at Lake Tahoe like a clock, Incline Village, was where I am, is at the 1 o'clock spot. So it's right in the north part of it.
So you're
I'm in Nevada.
You're in Nevada. Oh, okay. That's great. I've never been to Nevada, California a very long time ago. Actually, during 9/11, I was in the NTC, the National Training Center, when that occurred. But I never had the chance to go to Nevada. But I'm going to work my way up through a lot of things now that I'm getting hopefully closer to retirement and not with this, of course, but with, being able to support myself. And
Sure.
I'm enjoying it. And Terry, please do us a favor here at the Eye and tell us a little bit about yourself, where we can find you and what you're promoting today.
I appreciate that. Thank you very much. Actually, I'm not an author for my regular job. I'm an oral and maxillofacial radiologist, and that's not that easy even for me to say. So oral and maxillofacial radiology is a specialty within dentistry. I practiced clinical dentistry for 26 years, and I went back into a residency at 55, what you call non-traditional. And with a bunch of, I say young kids, they're like 28 and 30 years old. I'm 55, and I'm starting a new profession. But radiology, oral maxillofacial radiology, is a specialty in dentistry. And dentistry, unlike what people might think, is based in sciences. And I just had a mind for it. And all of that science has been bouncing around in my head for years. And I just pick up this stuff here and there. And my approach to, and I'm going to get into this a little bit later, my approach to looking at the world and the universe is through the lens of energy. And it's a unique way of looking at it. And energy is assumed in fiction or science fiction. But in reality, it is the story. Nothing happens without energy. And I hope that your audience, if nothing else, will leave this episode with a different appreciation of energy, what it means to us. And I'll go into that a little bit more. It's a little bit complicated.
Absolutely.
Because energy, we're so awash in energy, people just assume that it's always there and it's just free for the taking. But Energy is not free
Okay.
for the taking.
Yeah, yeah. It's if energy was free for the taking, then Wyclef, the Tesla's Wyclef, would be a little bit more of a reality, wouldn't
Yeah, wouldn't it?
it?
Yeah, there's a sense. Even Nikola Tesla kind of sort of seeded that flower bed, that the idea that you can just extract energy out of the air, right? And there's this idea that that can be done. And the truth is that there's an abundance of intelligence and imagination and creativity, but there's not an abundance of energy. The universe in its entirety has a lot of energy, but it's very diffuse. So if you look at how spread out, and I will talk about this a little bit more, everyone has a sense of it already, that this place is gigantic, that we're just one planet, one sun, in a galaxy of hundreds of billions of other suns, presumably with similar type of planets. But there's 2 trillion like this throughout the universe. It's just vast beyond imagination. So when you focus in on the energy of the sun, yeah, there's a lot of energy, but it's not just energy free for the taking. And that's kind of the heart of my book. So, like a lot of books, Tom, there's more than one story in it. And Where Are the Little Green Men is similar. The focus of the book primarily is centered on the Fermi Paradox. And I love this idea so much. And the Fermi Paradox is an idea. The paradox is, as I just described, there are so many, literally countless other planets out there and other stars. There has to be other intelligent life. There's just no way, mathematically. Even if you take a small fraction of that, that's still hundreds of thousands or millions or even billions. There's so many. But yet, we don't have scientific. Now, this doesn't take away from anyone's belief in extraterrestrials, ETs, aliens, or anyone's experience for that. It doesn't even touch on that at all. Because I had my own experience many, many years ago when I was younger, and I had no explanation and still do not today. Now, I didn't see a creature.
Sure.
I haven't been to a museum and seen a taxidermy ET, right? Or a spacefaring craft. I haven't seen that, but I don't doubt that. But the Fermi paradox is from what we expect and what we scientifically observe. That's the paradox.
Okay.
And it has Enrico Fermi's name because offhandedly, 70 years ago in a lunchroom, he happened to mention or ask the question, where is everybody? And that's the question that's lingered. And that question has gotten his name. He went on to get a Nobel Prize, but not for his paradox. That was not his area of specialty. So
No,
the
that wasn't
last 50
his
years,
strong suit.
there have been so many explanations for the Fermi paradox, all kinds of them, to try to explain why we haven't seen as many, or at least we don't have them landing in universities, right? We don't have that. We have plenty of anecdotal information, people's experience, whether they had a vision, abduction, or whatever it may be. These type of reports, but scientifically, it hasn't kind of met that bar we want. So that's what the Fermi paradox is. Just kind of that issue. So
Okay.
my book talks about my approach to answering the Fermi paradox, which is one of energy. The next one is what makes our planet so special. And Tom, I'm a little bit surprised by this, and I understand it's human nature that we get up and we have this experience that we've had our entire life, basically all of this abundance. And it's easy to take that for granted without recognizing where did it come from. And I'd like to get into detail about what the history, the evolution of that is. And so
Okay.
that's the second one. What makes our planet special? Then the third one
Yeah,
is
I would. Yeah, sure. We're
I
having a little bit
I'm
of a delay on timing
yeah,
here, so
I
things
know.
are going
So
to kind of.
I'm trying to work with
I
that
got to
too.
make
I
sure.
appreciate that.
Yeah, we'll be fine. We'll make it work, buddy.
Thank you. So the third part of the story is one of hope. And this is my favorite part of it is there is I guess people are just generally that way. You have your optimist and you have your pessimist. And I tend to be an optimist. That's kind of where I fall. And I'm just chemically or neurologically wired for that, as being more optimistic. And that is the hope, not only for us as people, but for humanity and beyond. And so I take this story and speculate one day we might be the little green men. We may have to launch ourselves. Now, people, before you sign up, this is a one-way trip. It's too big. There's no round way.
Count me
There's
out.
no round trips. It's one way. But I'm not the first, Tom, to come up with this, because others have suggested that in order for us to reach out, because the distances are too great, our travel is too slow, it will be multi-generational necessarily. And at some point, we may launch different probes that go in different directions, that don't necessarily have people, but carry that message, the message of hope, the message of consciousness, the message of knowledge. That's what we know we have that right now. And that's what makes us special.
Yeah, I
So,
like that.
go ahead.
No, I like that. I like that concept that you're looking at humanity through the lens of hope, consciousness. Hopefully, love is in there somewhere as well. The ability to project into the future and future generations, and wanting things to be better for everybody. I hope that's a really great message of hope. I like that.
Yeah, Tom. I think going back to the Fermi paradox, we all have that paradox ourselves, and people did long before Fermi kind of got his name assigned to it. Everyone is probably as far back as we can imagine have looked to the heavens and wondered what else is out there. Are there other people? Are there intelligent beings out there? And so it's through all of history of mankind maybe been more of a philosophical or religious issue rather than scientific. And so
Okay.
my approach has been let's nail this down. What are the chances? What does it take to be an advanced civilization? And a couple of pretty surprising things have to happen in order to create a advanced civilization. And I propose that not only are we intelligent people, then that doesn't mean wise, right? Those are two different things. We're intelligent, but we may not always be wise. So the key is to understand that we are intelligent, and that's evolved itself. That didn't just happen. Planets don't come preformed with little green men at all. And the interesting thing about when Fermi introduced or had that offhanded statement, "Where is everybody?" 70 years ago, we didn't know nearly as much about our universe, our own solar system, our galaxy 70 years ago than we did today. Isn't it interesting that, and I'll talk about Frank Drake in a few minutes, even when Frank Drake wrote his more formalized equation of that in 1964, we still hadn't actually observed a planet outside of our own solar system. We speculated that they must be there. And over the many decades since then, we've understand planetary formation a lot better right now. And I think about 15, maybe 20 years ago, thereabouts, in the 2000s, is the first actual eyes on, okay, those are planets. Now we actually see planets. And
Well,
so
they're not actually seeing the planets. They're seeing the gravitational pull of it as it orbits the star and the wobble of the star itself. If that's understood correct.
yeah, that's right. That's part of it. But some of the space-based telescopes have gotten so good that we actually can see them now. Yeah. The problem with
Oh yeah,
visible
yeah.
light
I'm just saying
alone.
you're referring to 20 years ago.
Yeah. Back then, sure. Pardon me. Oh, I pardon me. Yes. Yeah, even before
No, no
that. So
worries, no
certainly
worries.
60 and 70 years ago, we did not have the ability to use the telescopes that we have today. So you're right. So it was theorized that based on their behaviors, gravitational alignment, that there must be planets. So now that's been completely confirmed. And we're getting more and more planets. I think like 1,500 to 2,000 that we've actually observed, which is quite a few.
Wow.
So that is growing larger and larger. So that really helps the idea that, yeah, there are other planets. And I mentioned it earlier, and I'll go ahead and talk about it now. So I'll get into how this all sort of unfolds. So everyone's familiar with SETI, right? The
Yes.
search for extraterrestrial intelligence. That was actually founded, and Frank Drake was part of that group, that they wanted to create some sort of mathematical formula or framework. Is there a way that we can come up with a number? So they have the number of habitable planets, or where life emerges, and they have a bunch of these other factors. How often stars, or how often, this is focused on the Milky Way galaxy. And we know now, this is, the human brain simply isn't equipped to understand the passage of time in the hundreds of millions and billions of years. It's not equipped to understand these distances. And it's not equipped to understand these numbers. They're so mind-boggling. But the most current estimates is there's about 400 billion stars in the Milky Way galaxy, our own galaxy. And it's
Right.
100,000 light years away. And most people understand that a light year is the distance that it takes for light to travel through the vacuum of space. So our 400 billion planets, and it is kind of disk-like, our Milky Way. So as
Yes.
it's portrayed, it's pretty accurate, this sort of disk-like. And from edge to edge, it's about 100,000 light years, and there's 400 billion stars, each with some number of planets. Ours has 8. Poor Pluto got demoted
Right. Yeah. Yeah. I
to
remember
a dwarf
that.
planet.
Yeah.
First,
It's actually got
Pluto doesn't count.
it got demoted from planet status to promoted to the largest member of the Kuiper Belt. But whatever. It's semantics.
Yeah, exactly. People still fighting for poor Pluto.
Yeah, I'm with them. Well, it's on a different plane, but also like to kind of add on to what you're talking about is that not only is it 100, was it would you say 100,000 light years across,
Right,
and
right.
that's how, and I can't remember the number of the billions of stars, but we have observed that there is more galaxies in the universe than there is grains of sand on all the beaches of Earth. So like that, then your mind even goes even further to the, all right, what is this?
Yeah, try to wrap your hand around that. Anyone's been to any beach, all the beaches, there are more planets than there are grains. That's a number that we see, we can't handle that. And so the thinking that there must be something out there is totally natural. And I think it's completely correct. There is life out
Me
there.
too.
There's zero question about it. But I will get in a little bit more detail about the particular constraints of what it takes to be advanced technologically and how you get there. People are going to be surprised by this. I can't wait to kind of, as this unfolds.
Yeah,
So
I'm on pins and needles myself, buddy.
So in 1964, Frank Drake and his team started SETI, and they came up with a framework to sort of formalize that. And interestingly, I've just written, it's in the editor's hands right now, a companion book of Where Are the Little Green Men. It's called Earth, the Goldilocks Planet. Because everyone's heard that term before, the Goldilocks Planet, right? Or the Goldilocks zone, or the habitable zone. You've heard that, is that right, Tom?
Absolutely. It's the area between where I think water can evaporate and where it would freeze. So I believe the Goldilocks zone kind of is right outside of, in our solar system, outside of Venus, right outside of that, and then I think Mars is still within it, but barely within it, if I remember correctly.
Yeah, that's exactly right. So it's the not too hot, not too cold zone,
Oh, yeah,
and that
okay.
was sort of
Much better synopsis.
right. Yeah. So Goldilocks wasn't that wrong. In fact, in my new book coming out, and that's not what I'm talking about today, but it's a companion book. It actually is, pardon me, it actually formalizes the idea a little bit more. And I'm actually proposing a reframing of the Drake equation based on our information gained over the last 60 years since it was written. And so
Very
so
cool.
it really is a companion or extension of this same book. It's just a little bit more formal in some of the things, but I've tried to write it in a narrative way rather than who wants to read a high school or college textbook, right? You want something engaging, something that'll keep you awake, something that's interesting, and I hope that I've delivered that in my book. And I think the book reads very much like I'm saying. It's not full of formula. It's not what people want because it's an amazing story. There's no brand new science in it. But Tom, I can't believe in 70 years, and I've done a lot of this, and I've used, and anyone can use it. I want to know myself. I've given my book to at least a dozen AI machines, and all of them said the same thing, that this thought is original. That no,
Cool.
even I went to London in January to hear Brian Cox. Are you familiar with that name?
I am. He is somewhere's way up there in the theoretical physicist area, if I remember right. I
Yeah,
think he also
right.
co-authored a lot of books, and yeah, I know a little bit about M theory. Maybe I don't know if that's him or not. I can't remember exactly.
So you're thinking of Brian Greene. He's the string theory guy, Brian Greene.
Okay,
So Brian
I used to
Cox, it,
be a big fan of this things. This is my knowledge of this kind of went away. I used to read it when I used to go windsurfing in the Netherlands and things like I used to live in Europe for 2 decades.
okay,
So
cool. Oh,
yeah,
nice.
yeah, I've been yeah in Mexico now, man. I've been around the world. I got a book in the making too. I
Good
have
for
a working title. It's
you.
going to be called The Religion of the Heart. And
I like it.
things it just I woke I, you know how like a lot of ideas come to you when you're halfway between the dream world and the
Oh
awake
yeah,
world. That's where most
right.
of my jokes come from. That's where most of my music comes from, and that's where the title of the book came from. But yeah, I used to sit there
Love it.
on the beach waiting for wind to come and would read these kind of books. Yeah, so I'm
Yeah.
kind of I think he was on the Joe Rogan podcast if I remember right.
Oh, he's been there a couple times. And you know what?
Okay.
This is interesting. Thanks for bringing that up. So the interesting thing is that Brian Cox is a particle physicist. So he is, in some ways, he contributes to or is very familiar and has been to CERN, the Large Hadron
Mhm.
Collider, which is probably the largest, most sophisticated experiment man has ever created, and that's saying
It's
something.
not probably. It most definitely is. It most definitely is.
Do,
Even
do, you, do you
just
know,
the
Tom?
collectors, just the
That's
collectors
it. That's that. Yeah,
themselves.
the detectors are so amazing. In fact,
There's
right
two different
now
ones, I believe. I think there's two, at least
they're
two.
getting new ones. It's
Oh,
undergoing a
really?
4-year upgrade, so it's going to be silent for 4 years. And they're putting in new detectors
Hmm.
because the way this works is protons are circulating around this like 17-kilometer circle in opposite directions, and they collide into each other and all this stuff.
Yeah.
What we're doing with this is when these protons collide, it creates all of these other exotic particles.
Yes.
And quarks are the supposed fundamental particle of protons and neutrons. The electron is on the outside, and the
Hmm.
protons and the neutrons. So we've known about protons and neutrons for about 120 or 130 years, maybe 120 years. But when you have
Yeah.
high school and college
It's
chemistry,
also where they theorized the what they called the. I'm sorry. Where they theorized that the it was called the God particle or the big Higgs boson particle was theorized, and they were able to actually see it. I believe that was in 2012,
12
and
exactly. There you go.
I
Yeah,
was living in Europe.
yeah.
It's really interesting. You can live in Europe, and I have a lot of my students. I'm an English tutor as well, and so I have German students because I speak German. So I'm talking to them, and I'm like, "Hey, let's talk about the collider down there." He's like, "What?" And they don't even know what it is. I'm like, "It's you don't know what that?
Oh
That's
my
crazy."
gosh, that's awesome.
He didn't know what it was. I was like, "You probably drove right past it
He
many
probably
times."
did. Well, it's so big. You had,
Yes,
I
I
mean,
know
it's
he
hard
does.
to, yeah, you had to go by it, around it, or through it, or not under it, but over it, whatever. So
Yeah,
that's exactly right. The Higgs boson, Higgs and his group, no one knows the rest of them. It has his name, but he was not alone. He actually theorized the Higgs field because the universe is full of fields. They're invisible fields that permeate the entire universe, and everything interacts with those in each has its own particular way. And so he theorized the Higgs field, and therefore there must be a Higgs particle. Again, 50 some years before it was discovered, they actually captured
Right.
the, as you said, correctly said, they captured the particle in 2012. But it was 5 or 6 years before scientists agreed, okay, that really is it. It took them that long. They wanted to be careful with this. And
Yeah,
so it was
it's
about
called science. I like that.
2017. Exactly. It's like 2017. It's like, okay. And fortunately, he's still alive then. He was alive then. I'm not sure if he still is. Um, to finally 50 some years later to find out that, yeah. And so that particle is what imparts mass to other particles. Because if a particle interacts with the Higgs field, then by definition, they have mass and can never travel the speed of light. Photons do not interact with the Higgs field, therefore they must travel the speed of light. There's no choice. So that's where those came. So that it is kind of the God particle. So if you interact with Higgs, you necessarily have mass and therefore can never travel the speed of light. That's where that
And
comes from.
photons are so interesting. Photons are so interesting because they act like a wave as well as particles. It's a very, with the double slit experiment and all those things. You're just like these are they're very rare. They're like right between Newtonian physics and like particle physics, and people are trying to then put those together and make
They
that
don't work,
unified
right?
theory, and they're
Right,
having a very difficult time with that.
right. Yeah, because it's interesting in everyday. I'm sure most of your listeners know this. Photons are light, but they're not just light. They are in the entire spectrum of the electromagnetic radiation. So on the least lowest energy, you have radio waves, and the very highest, you have your cosmic rays. And the visible light is somewhere kind of in the middle. But that's
Right.
all photons. So a radio wave is a photon. It is the force carrier of the electromagnetic radiation. And so you're exactly right. It's not a particle because it doesn't have mass, but it
Right.
behaves like a particle and a wave. And here's the thing that I don't get this either. What you see is based on you looking at it. That's what's so weird.
Mm-hmm.
If you don't look at it, it behaves the other way.
Yeah,
No one gets
Schrodinger's
it.
cat, right?
Yeah, exactly. And so the quantum nature, quantum just means it's packet. It's a size. It's an energy packet. That's what a quantum is.
Okay.
The energy
Okay.
energy travels in packets.
Okay. Wow. I mean,
So
I'm learning things and bouncing things off of you. You were able to give me answers. That means I'm not trying to test you or anything.
no, I
I haven't
understand.
had this
No,
discussion yet on the podcast. So for
yeah,
me, it's just interesting, and I'm enjoying it. Please, man, continue. It's
awesome. Thank
wonderful.
you. So I went and saw Brian Cox in January. I flew from Lake Tahoe to London. I'd never been there before. If you were in Europe, you've been there. I loved
I
it.
flew through London.
Okay. Okay. I loved it. Fortunately for me, you speak German, maybe another language. I barely know one.
A little Spanish.
So they speak my language there.
Kind of.
Anyway, I went to see Brian Cox, who is, among other things, besides being a particle physicist, and he works at some the college I don't remember. It's near London. So anyway, he talked on his show, and I went there to hear this. The entire second half of his show was about the Fermi Paradox, and he never talked about energy. So the highest minds have kind of overlooked this small but important detail, which I believe is one of the most critical details that will determine if advanced civilization or even intelligent life can ever occur on any planet. So
Okay.
that's why I believe that my idea is in its own space right now, and I'm a scientist. I'm not a mad scientist in a laboratory with test tubes and boiling water and colored solutions and stuff, but I'm a scientist, and that's how I've been trained, and that's how I think. And dentistry is based in science, and so I've collected all of these thoughts of energy and all this for many decades. And the book came to me at one time, and people have asked me. I mean, I'm a radiologist. I'm an Ironman triathlete. I'm a wakeboarder. I'm a snowboarder. I'm
Yeah.
a paddleboarder. I live the
Dude, you're like me, dude.
multi-sport
I'm a
lifestyle.
snowboarder,
Yes.
windsurfer, cross-country skier, dude. Let's
Okay.
go. And
Oh,
a painter,
perfect.
and an oil painter, and a comedian, and a musician. Let's go, buddy. Let's go.
Well, you
I'm
know what, Tom?
serious,
This
man.
is what you have. This is what you have, and I don't. I
What's
don't
that?
have a creative bone in my body, right? So
Well, how did
I
you make
lack
the book
I,
then?
I lack those things. Yeah. Well, again, this it's not new science, but I have synthesized an idea that people have kind of danced around and never put it together in this idea. That's what makes my book different and my approach to Fermi different than anybody
Okay.
else's. So our planet, we know how planets are formed. As I mentioned earlier, they don't come preformed with little green men, or for that matter, any life at all. They're an
Okay.
accumulation of exploded stars. When you hear that we're made of stardust, this is
Yeah,
to
we
me
are.
this is freaky. We are. We're made of stardust.
Yeah.
All of those products, and this is an amazing thing. You look at a sun and you might imagine that there are little men in there putting coal into a furnace. Nothing's burning on the sun. That's fusion.
Yeah.
Isn't that amazing? That's fusion.
Yeah. Yeah.
And
We are a carbon-based life form, and carbon atoms are created under. They have to be created under extreme gravity, which is basically the first generation of stars. So the first, helium and the hydrogen, then turn to helium, and those stars exploded fast within the time of the universe, creating the second, third generation of stars, which gave birth to these newer stars that then can create. I think, as far as you probably know better than me, like carbon-based life forms, which enable us to actually have life here. So stardust, yes.
that's beautifully said. That's exactly right. If
Thank you,
if
sir.
if I if I can, let's come back to carbon-based life form. I love this, people.
Okay, sure.
When we go to another, I won't be there, darn it. But when humanity reaches out or someone comes to us, two things, okay? I can assure you this, and I'll tell you how. This is not a wild guess. They're going to be carbon-based, and they'll be like us. Those two things, almost for
Okay.
sure. Okay,
Okay, I
so
like that.
they
All right.
they won't be exactly like us, but almost definitely they're going to be carbon-based, and not because God likes carbon better than the other one. There are reasons. Each element
God has a carbon
behaves.
bias.
Yeah, he's carbon biased. Each element has its own properties, right? They do.
Okay.
Carbon is the molecule of life. It is the backbone of life, not only here, but it will be elsewhere. And I'll come back to that. So you're already right. We're made of stardust, which is awesome. What we're made of was born in the furnace of stars billions of years ago. They explode, but here's the thing: up until iron, all of that is created in just the right type of star. Our sun will not fuse to iron. Okay, it's going to expand and change, but it doesn't have the size, the gravitational size, to fuse the larger elements. But in
Mhm.
the biggest stars, iron is as far as you can go and still get energy. That's the key. So what's happening is you're exactly right. Hydrogen is being squeezed together so tight it makes helium. 3 heliums make a carbon, basically. That's where we get carbon. And so you have to have the hydrogen fuse into helium, and then eventually the helium will fuse into other elements, but 3 of them will fuse in to make carbon. And the other elements, oxygen, nitrogen, so all the way up until iron. Now here's the thing: the heavier elements are formed when a star goes nova, because it reaches so much energy that now you can overcome those forces required to squeeze 2 different elements together to make another new one, which is amazing. And they explode out to the universe. And then, get this, it takes colliding neutron stars to create the very heaviest elements like gold, uranium, etc. Isn't that amazing? So you're exactly right.
Yeah,
You
I
don't
like it
get
though. It just makes
gold.
it makes sense. I don't. Yeah, I never studied. I never went to chemistry class. I was always in earth sciences and things like that because it just I didn't need it. But I developed interest for it later, and I love supermassive black holes, and I also
Right.
nothing escapes the black holes, and then all of a sudden there's Hawking radiation. You're like, well,
Hawking
there is
radiation.
something. Things, yeah, just there's yeah. These are things that I've learned on my own. I mean, school never
Good.
taught me that.
Yeah. Yeah, and that's exactly right, that even a black hole will eventually evaporate. The time scales are unimaginable. I mean, we can't even imagine hundreds of millions of years, let alone get this, trillions of years, which is how long it takes for a black hole to evaporate. Everything entropy wins.
I'm
You're
having a
familiar
hard
with the
time remembering yesterday, my friend.
both of us, both of us.
Yeah, I can't
So
even. I can postulate out maybe a year, but that's about it, man.
yeah, exactly right. I'm going to say a couple of things right here that I think are really important because we're kind of converging
Okay.
on a point that each will need to be spoken about a little bit separately. Two things have to happen. Two very, very improbable events have to happen to have intelligence and energy. That's the key. And they have to happen more or less simultaneously, both improbable. So you already know how difficult it is that anyone who's played the Super Lotto or whatever. I don't know the numbers, whether they're hundreds of millions or tens. I don't know what the odds are. But any large number can get reduced. And so if you take and pick a winning Super Lotto ticket, right? And you win again the next week, and then again the next week, and then again the next week, 10 or 20 times, the chances of that happening gets very, very small very quickly. Well, the same thing is true with what's happening in our planet. There is a bit of a known probability of some of these things, and that's where the Frank Drake equation can be slightly modified. We have a better idea. Here's a good example. You hear about the habitable zone, right?
Yes.
75% of the planets will never host complex life right there. 3/4 of them, at least, will never. You know why? They don't have the right energy flux. If you don't have photosynthesis, some of you might have been thinking this already. If you don't have photosynthesis, you'll never have complex life. You'll never have complex multicellular life. You'll never have advanced civilization without photosynthesis. Never. Or an analog, or some analog. So you have to have that eventually leads to coal, oil, and gas. You have to have that. If you don't have a readily accessible source of energy, your civilization won't. Well, I can prove it. We already had all of those civilizations before coal, oil, and gas. We had those already. That was our own experiment on planet Earth. Many of them just disappeared. Now, there's a lot of postulation of why that happened, but there is an absolute firm ceiling, hard ceiling, on how big a civilization can get. So you have to have that.
Okay.
And you also have to have the evolution of intelligence. Those two things have to come together to create something like us. So the chances of those two things happening on any planet is vastly small. But again, there's a lot of planets out there. So let's get this kind of tease these out a little bit, each of them. So the habitable zone, 75% of the planets, the suns, may host a type of life, but no more than simple life. And that's important. I want to know that too. We all want to know that. In fact, we're going to Mars as part of one of the things that we're trying to accomplish is to find out if there actually was life on Mars, early on. That would be remarkable. Are you familiar, Tom, that even on Mars and on comets or asteroids, and even meteorites that have landed on Earth, there's organic molecules in them.
Yes. Yes. Of course.
So that suggests that the molecules of life are throughout the universe. And those
Okay.
molecules, under certain situations, can become more and more complex. Now, I went back. I don't want to teach a high school chemistry class. I love it, though. I would be a good high school chemistry teacher, I think. I love it. Um, nothing, not one, not even a handshake. Nothing happens without the exchange of energy. No energy, no complex molecules. Plain and simply, it does not happen. And the speculation is, and you and your audience have probably heard this, that life began on our planet in water. That's the medium. So that's why you have to have liquid water. So you have compounds kind of bumping into each other. And when you add some sort of energy, then new bonds get formed and you can create more and more complex molecules. And it's theorized that maybe the energy came from lightning strikes, right? Because there's energy there for sure.
Hmm.
We have zero capacity, people. I'm sorry. There's a lot of lightning out there. We don't capture it. Yeah, it
No,
would
they
be
can't.
nice. All right,
No.
we don't capture it. It's a vast amount of energy. There's zero way for us to capture and utilize, but small molecules can. But I think the more widely accepted idea, and it may have been both, that life began in the hydro vents down in the ocean.
Oh,
There
okay.
was
Like on
warmth
the Mid
there.
Atlantic Rift.
Right, there you go.
Hello,
So
kitty cat.
he woke up from his nap. He has a rough life. So one of the ideas is that they have hydrogen sulfide, H2S, and warmth coming percolating out of these vents deep in the ocean. And that allowed the opportunity or created the environment for simple molecules to bind together and make more complex ones. Going back to something I said earlier, we have zero capacity for understanding 4 billion years. This is incremental. This is how evolution works, incrementally.
Mhm.
Evolution doesn't start and says, I want to be grown up. When I grow up, I want to be a human. It's not how it works. Flight, vision, hands, all of these things, intelligence, there's no goal for evolution to reach those. Evolution has one goal only, reproduction. That's it. And it's created all these fascinating ways to ensure that this is weird. The DNA gets duplicated and reproduced. That's what this is all
Um,
about.
I know that this is
That's
not
too
the
freaky.
place. It's no. It's not the place to do it because you're presenting your idea and I'm here to listen to it. But I would love to, maybe in another time or when your second book comes out, to get into where does consciousness come from?
Yes. Thank you.
Is everything just material science? And
I
if
love
so,
that. Yes.
then if
I do have my
so,
ideas, but I think we can. Yeah. Thank you. Yeah.
then if
I
so,
love
then
that.
where does I love that, like just a philosophy, a little bit of philosophy, because philosophy is basically the precursor to science. But
Right.
I think
Yeah.
there's, just like alchemy is the precursor to chemistry, but there's
Right.
something there that we are looking over as well. We're not looking into, your love for your cat. You can see your cat loves you. He's laying on your lap. Is that just a chemical reaction within the mind,
Yes.
or is it just an
Something
evolutionary
else.
thing? I don't know about all that.
Yeah. Yeah.
Yeah.
Thanks for pointing that out. But Tom, you do agree we have consciousness. We are able.
Um, it's like
Well,
agreeing that I
consciousness
have free will. What if I don't want it?
consciousness exists. Okay.
Of course. Oh no, I was joking with
Consciousness
you, man. But
exists.
of course, consciousness exists.
Right.
I believe I have my own way of looking at it. We can. I don't want to go down that rabbit hole, but yeah, of course. If you're just for the limitations of this, presenting what you're presenting your book here, yeah, of course.
So that's why we need to keep it going. We need to send it out there to keep consciousness alive. And however it manifests itself, and that's a good discussion. So the life evolves incrementally, and eventually cells developed. They're very, very primitive, and they had primitive RNA, which is what the original genetic material was presumed to be. And then DNA was created. And again, I don't want to get into be a high school biology and chemistry teacher, this happened incrementally, very, very slowly, a long period of time, where you had now actual cells. Before they were just had membranes that weren't very sophisticated. And then over time, the membranes got more sophisticated. And then they got organelles inside that were sort of divide up their labor. This is for energy. This is for replication. This is for protein synthesis, et cetera. And so the organelles within the cells became more and more complex. And again, this plays out over millions of years. And then eventually, because our world is bombarded by a bunch of different photons of different energies, we already know that the high energy ones, X-rays, right? We're kind of worried about X-rays and gamma rays, whatever those things are, right? They're high energy waves. Well, the one thing, and you may have heard this, the term of ionizing radiation. Ionizing radiation starts at UV. And again, the energy is a spectrum, so it's not just a single wavelength, but there's a spectrum. Beyond UV, everything beyond that energetically is potentially ionizing, which means it splits molecules apart. And so if it's too ionizing, then life can never get started, because you form a molecule and you instantly split it apart. And that's the key. It's not a Goldilocks planet. It's a Goldilocks sun. It's a Goldilocks spot in the galaxy. Those are, so if you're too close to the center of the galaxy, no, life won't form. You're too far out, you don't have all those rich, yummy items.
You also have to have some type of magnetic situation going on with the Van Allen belts, because that is super important.
Yeah,
your sun can't be shooting out too many, like solar flares. There's a lot of things that have to be perfect. We have this wonderful 22.5-degree incline for it's a perfect planet. It's beautiful.
Tom, you just wrote my book.
But no, this is your third one. Okay, just put me in at the beginning there. Just put the iJupiter podcast at the bottom, where we're good. But
yeah, exactly. So you're exactly right. All of those things add up, and they're all critical, because the sun is constantly bombarding us. And so we have this magnetic dynamo going on that creates this electric field. That's where the aurora borealis has come from.
Beautiful.
And so that's an actual example of these particles trying to come down and ruin molecules. And so what happened is something freaky happened in a early single cell organism. It developed a pigment, a molecule that captured that harmful radiation, okay? And the molecule got harmed, but it didn't harm the cell.
Okay.
And then they figured out a way, I say them, I'm referring to the small unicellular organisms as they. Then they figured out, oh, there's energy here. We can capture this energy and we can make more molecules with it. And over maybe not hundreds, but billions of years, photosynthesis occurred. That's the key. Now we're tapping into a brand new source of energy. Planets don't have energy. Now I'm going to get back to uranium. So you're smart people say, oh yeah, the good doctor doesn't know what he's talking about, because there's uranium in there. There is uranium, and there's thorium in there. And those are energetic, and we can and we must use them for our future. We absolutely have to use them. We can't keep burning fossil fuel. We're burning a lot. We can't keep doing it. So you're right, but you can't go from campfire to nuclear reactor. I'm sorry, folks, that doesn't happen. Intelligence is not the limiting factor. It's energy. If you don't have an energetic pathway to get to these other, climb up that ladder, you never get there. We're only able to say that because we have that. And so because we're so awash in it, fish don't think about the water that they're in, right? We no longer think about the energy. When you turn on that switch, you want the light to come on. Most people have zero idea where electricity even comes from. That's fine. I mean, it's not a criticism of people. We don't have to think about it. When you turn your car on, whether it's a battery or gas,
we're
you don't have to think about where it come from. Right. We're specialized.
Economy, there's a lot of things that certain things I know that you don't know, and certain things you know that I don't know. That's why communication is critical. I wish people would learn that again.
Yes. So photosynthesis is the key, or an analog, to complex life anywhere in the universe. Your planet does not have anything. It's barren rock. The soil that we have, that came from photosynthesis. Photosynthesis
Yes.
terraformed our planet slowly but surely over hundreds of millions of time, unimaginable spans of time. It creeped out of the water. It was not a redwood, people. That's not how it works. We have this vision that all planets have these giant, massive trees that we're just used to. You look at it. Well, I'm in the forest, so yeah. When I look, I don't see redwoods, but I see a dozen different pines, right? And so we're just used to that. That's not how it started. It started out by something crawling on the rock, and it transformed this rocky planet. It got a hold. Then it was able to use those nutrients. But the key is the flux of the energy from the sun. And photosynthesis happens in a very narrow band. Now, I did not think of this as an original thought, but I was thinking that, oh, I got it. Photosynthesis it happens to be 400 nanometers to 700 nanometers. That's our visual light too, and that's not an accident, because if it was
Okay.
too high, it would harm us, right? So you can't use high energy to look at. Now, some insects, it's proposed, and even some people actually can see a tiny bit into ultraviolet and a tiny bit into the infrared. So again, it's not a hard line on these. But photosynthesis and our vision is keyed into a very specific wavelength of energy from our sun.
Mhm.
75% of the stars in the universe are the wrong energy flex to have photosynthesis. So you'll never get above that level of energy. You'll be single. There's nothing wrong with single cellular life. I'm not making a moral judgment. I'm just saying this is a constraint that people don't talk about. They say the habitable zone, meaning that if you're blank distance from your star, yeah, you'll be warm enough, plenty warm. You won't be too hot. You won't be too cold. But you won't have the energy that you need for life to flourish on your planet. Water won't freeze. You can have simple molecules. You can have, because we already know that there are molecules throughout the universe, but you'll never have complex life. It all comes from photosynthesis. So to kind of speed up the story a little bit, that's where coal comes from. That's where oil comes from. If we didn't have hundreds of millions of years of photosynthesis burying all that energy below us, I know, I know, I understand. It's an uncomfortable topic. I'm just delivering the message. Without coal, oil, and gas, we wouldn't be here. We are 100% dependent on it. We are so dependent on it. I think we should have a world celebration day of fossil fuel instead of condemning it. We should celebrate it.
I wouldn't condemn it whatsoever. I mean, you know, it's kind of weird. Like we have this really cool balance where, like, that the plants breathe out oxygen and we breathe out carbon dioxide, and now the planet is actually greener than it's been in a very long time. It's also
Thank you
weird
for saying that. You're exactly right. Yeah,
for that.
I believe that what I just heard most recently is that in the last 10 years or something, the Earth has become greener by a factor about the size of the United States, is how much greener it has been. We
Yeah,
can't
some
imagine this number.
craziness.
Okay,
Yeah, man.
okay, Tom, you're going to love this. Because you said something that a lot of people don't understand, but I'm gonna even blow your mind a tiny bit more. You take your apple and crunch into it,
Sure.
right? You eat your rice and your potato, you're eating atmospheric carbon. That's what you're eating. You're eating CO2.
Yeah.
CO2
Well,
is not CO2 is not plant fuel. It is the plant. That's the magic of photosynthesis. It takes atmospheric CO2 and makes a tree out of it. So
awesome.
that tree is CO2. It's not the fuel. The fuel is the sunlight. The tree, the corn on the cob, the apple, that's atmospheric CO2 that you're eating. And in the greatest,
Okay.
most remarkable thing, it started to release oxygen. Now, that oxygen poisoned the earth because everything was anaerobic at that time. Oxygen
Okay.
kills, oxygen oxidizes, it's highly reactive. It wiped out most of the organisms on earth. All of the iron in throughout the crust turned into rust. Imagine this. Imagine all the iron. Imagine all the molecules Most of the minerals, the beautiful gemstones we see, they're oxidized iron, or pardon me, they're oxidized metals. So your rubies, your sapphires, they're oxidized metals. Those came after all that came from photosynthesis. Everything came from photosynthesis.
Beautiful.
And eventually, after everything that could react with oxygen reacted, it began to fill the atmosphere. Now, if you think of just regular simple glycolysis, you just burn your glucose, for example. That's the basic fuel of life. So if you just burn that, you don't get very much energy. But you burn it with oxygen 30 times. So now that's what allowed for, so we went through the steps, right? The simple molecules became more complex molecules, eventually became simple cells became more complex, photosynthesis comes on the scene, creates oxygen, and there's an explosion of life because we have 30 times more efficient burning of glucose just from that event alone. And that's what allowed the explosion of life right there. And so all of these niches opened up around the planet. And just what you said earlier, the tilt of the sun, the tilt of the earth is what gives us the seasons. The moon, its early crash with Earth, it was a planet itself and crashed into Earth and became our moon, gave us a very stable, not only orbit, but rotation. And we're not locked. We rotate. We're not locked. Like, the moon is locked with the Earth, right? That's why we don't see the dark side.
Yes.
So its orbit and rotation
Yes.
are identical. Some planets are locked with their sun. So one side is like burnt, the other side is icy. It'll never be anything else. So obviously complex life will never form there. That's another one of those factors. So we were all of these things is a complete galactic lottery. And so trees started to grow immensely, reaching for the sky as high as they could go. And it took lignin for them to do that. Lignin is the complex plant molecule that gives them rigidity, makes them stand up. They began on the ground, and eventually they learned to grow. It took, I don't know the time, but some time frame, millions of years, whatever it was, before any organism could decompose or break down lignin. So when trees died, they just fell, and more compressed on top of them. So they're the opposite of decomposed matter. So this won't happen anymore. It does a little bit in peat bogs, but geologically we'll never get coal out of trees that are alive today. That's where it came from. That lignin couldn't be digested, and it just simply got pushed down into the earth for hundreds of millions of years, and all of those complex tree compounds eventually became coal. That's where coal came from. Without that coal, and I don't know how much people want to hear.
That's why they call some coal brown coal. That's why brown coal is called lignite.
They have lignite and they have magnetite, so they have different types of coal. Exactly, because it just geologically, it was processed a little bit different geologically, and you'll see these resources aren't spread uniformly around the world, right? Like our oil, you have it here, you don't have it there. You have it there. It's just the luck of the draw, right? Now, if you look at it just from a human perspective, it's there for all of us to use, right? I'm not making any type of judgment on that. I'm just saying that's how it is. We just have to accept that. Now, politically, that's not how it was divided up, but some places have the oil, some places have the coal, some places don't. Some places have other resources. Okay, we want to make a new battery, we have to go to Australia. We want to make do this, we have to go to Africa. We want to make one of these, we have to go to India. So those resources are spread unequally around the globe. And partly because there's tectonics that shift that around, and that's part. If you don't have tectonics, you're not going to have this mix of all these interesting materials. So that's where the pantry, if you will, of life comes from. All of these molecules. So if you remember your periodic chart, pardon me, in your high school or chemistry class, you know that you have a list of all of the elements. That's not Earth or our solar system or our galaxy. That's the entire universe. That's it. That's all you have. So anything you make has to come from, and it's a big pantry, but most places don't have it. Most planets don't have all that stuff. Only planets that formed in their area of their galaxy, like ours did. The farther away ones, they don't have it. because they don't have that rich exploding previous stars and in colliding neutron stars that we talked earlier about. So without all those things happening, your neighborhood won't be stocked for you to make a planet rich with all these stuff.
Hey, I hope you guys enjoyed that interview. Much more to that interview. There's a lot more to that interview. And if you want to see that, all you have to do is go down in the link below. It's a membership tier called Inside the Eye, and you get any, how will I say this? Any interview over an hour. You guys can go ahead and click on that, $8.99 a month. And of course, all silver membership tier levels and perks will be included. I hope to see you there. Go ahead and sign up. Link in the description below.